because we really need to talk about something, and that is you guys are all loaded in your brain about correlation not being causation, and that's wonderful, except for that it's just not that simple. So I want you guys to think about what would be the purpose of doing any of these experiments or surveys or things if we can't establish causation at all. Like, why would we do it? Why would we do things if we can't say this new drug helps heart disease? If the cause shows this effect, what would be the point? Okay, and so we've been going over this because I want you guys to have like analytical brains. I want you to question stuff. I don't want you to be like, oh, I read this on the internet, so that means it's true, right? So I want you to like really be able to read something and just have like a little bit of doubt in your mind. I think that that's a much better way to live. And my son, bless his heart, is the nicest person. He's so happy-go-lucky. I just kind of wish my brain was like that, because he's just more like, great, okay, he just doesn't question stuff. My other child is the complete opposite, questions everything, drills you about everything. I'm trying to live somewhere in between my two children, but anyway, what I need you to do is know that you can actually establish causation. It's possible. So every question that you get, I don't want you to be like, correlation's not causation, that's it. I didn't read the question. I didn't do anything. Like, that's not true. Why we say that first a bunch of times is because last chapter was about correlation. So it was just about having a scatter plot. You can't determine causation off a scatter plot because it's just a bunch of dots. But you can off of a well-designed experiment. Okay, and so I want you guys to see the nuance of that today. And then, so my hope is we have a couple of vocab terms to put in on our blue sheets at the very end. We're going to finish this, which is just basically making conclusions from yesterday. And then I have a Kahoot, which reviews all the vocabulary and stuff from the chapter. So that's my goal for today. None of the notes or anything are very long, but important because I don't want you to just make assumptions. Okay, so start with the blue sheets. Start with the blue sheets, please. Okay. Okay. Using studies wisely. So this is unfortunately where you're going to have to engage the critical thinking. Everyone loves to do critical thinking. No, they don't. No, they don't. Not even me. Okay. The fact that different random samples of the same size from the same population produce different statistics. This is called sampling variability. And I don't know if you guys remember that video with the lady with the super cool accent. She said in there, there's nothing that you can do, even if you design the perfect study, there's always going to be variability due to sampling. Because if I ask 5 of you in this room what your preferred amount of tacos is, and I calculate that average, and then I ask a different 5 of you what your preferred amount of tacos is, they're not going to be the same. I mean, oh, they might be. There's a very small chance they might be the same. We pretty much all agreed that 3 to 4 tacos, if we're talking about the same tacos, is ideal, just from our survey results. But like, chances are they won't be perfectly the same. Okay. And then note that larger samples are more precise because you had more people to ask and it's a better average. So if I ask 15 of you what your preferred amount of tacos is, and then I ask a different 15 of you
what your preferred amount of tacos is, those numbers should be closer together. Does that make sense? Because I got to average more people. So the outliers won't be as significant. Okay. When the observed results of a study are too unusual to be explained by chance, this is called statistically, you know the next word, significant. Statistically significant results. It means that the results are too unusual just to be explained by chance. And for us in stats, we're looking for a p-value of less than 5%. Okay, now we're going to talk about that whole correlation is not causation thing. Okay, because you need to be able to determine cause and effect. Like, why would you do it otherwise if you couldn't? Okay, but it has to be very specific. Random sampling allows, and so what I want you guys to do is just write survey here because it's a really good example of what a random sample would be for. Random sampling is for survey, observational study. You can use random sampling to generalize your results to the whole population. This is stats magic. It means that you can take a sample of students and they tell you that the average number of tacos in an ideal meal is 3. And then you can say, all right, I can then assume that all of Mrs. Talbot's students, if I were to average them, the average number of tacos in an ideal meal would be about 3. It just cannot establish cause and effect. So you can generalize your results to the population, but not establish causation. I forgot the L. I said establish. Establish is not a word as far as I know. So this is your whole correlation is not causation. You can say that everyone thinks 3 tacos is best, but you can't say why. Okay, now random assignment. This is the key. This is different. This is an experiment. If you do a well-designed experiment where you do random assignment to treatments, you can establish cause and effect. Okay, however, you don't get to say it for everybody. Only for those like the subjects in the study. Okay, so let's just say that you have a very large group of giraffes. You tend a herd of giraffes, okay? And you randomly assign half of the giraffes to eat a certain kind of plant and the other half of the giraffes to eat a different kind of plant. And the ones that you give the special plant, they gain weight, the other ones do not. You cannot say that that plant will cause weight gain in hippopotami. Do you see what I'm saying? You can only say it for do it. So cause and effect, you can determine, but then you have to make a little note, but only for things like the ones that I did the experiment on, because I don't know about everything. And these are the things I want you to be able to read in studies too. I want you to be able to be like, oh, they randomly assign this to only people in the UK. Well, then the results only pertain to people in the UK.
can we use that maybe as a factor to help us make decisions here? Because we could have similar to the US? Sure, but I want you to have that little bit of like, well, they're different in your mind. Like, think critically when you're reading it, be like, this might not apply to me because I don't have the beautiful British accent and eat, wait, what are they, tea and crumpets?
Yeah.
Maybe it's their crumpet eating that is causing, Okay. Now we are actually done with the blue sheets, believe it or not. Okay. So keeping them next to me though, keeping them next to me, I'm going to answer these questions. We're going to answer this stuff about our hand reaction time clicking experiment for Wednesday. And then the last question, I'm going to talk about tacos again. But we obtained a p-value of what from our matched pairs experiment? Okay. And I sort of front loaded this lesson, but here was our p-value 0.014. We already wrote that our results are statistically significant. Okay, so we obtained a p-value of 0.0. Wait, was it 0.14? 14. Okay, sorry. I have short-term memory loss. Pausing here, I want to tell you two things. First, asking you about the p-value, calculating the p-value, those are things for later chapters. I do not want you to worry about how to get the p-value, from your calculator. Is there a formula to get p-value? We will learn all of that in the subsequent chapters from now. This is not part of this chapter. This is, as CPM book would say, a preview of further material. I will not be asking you about p-value on your chapter 4 test. The word p-value will not appear. This is stuff for front loading us for the future. Okay. However, I will be asking about statistical significance and what that means. Okay. Anyway, this means our results are statistically significant. We discovered something. Yay. Okay. P-value interpretation. I will not be asking you for this on your chapter 4 test. Assuming that there is no difference in reaction times between your dominant and non-dominant hands. Actually, interestingly enough, when we were clicking, one of the students told me that she was ambidextrous. So assuming that your hands are 50-50, right? One's not faster than the other. There is a 0.014 probability of getting the results we did just by chance alone, by using some kind of random chance, like table or random number generation or random time generation, something like that. Since our p-value is less than 0.05, it is too unusual to have happened by chance. There was only a 1.4% chance of it happening just under a simulation. So, what can we conclude? And I'm just going to put a big fat star here. I know I left space. I left space for so that your eyes would come to this spot in your notebook later. What can we conclude from our hand reaction time experiment based on its design? Okay, so what I mean by that is, did our experiment have random sampling? No. Did our experiment have random assignment? Yes. That means we can determine cause and effect, but only for those individuals like you guys.
Okay, so what does that mean? We can conclude this might feel weird for you because you've been always told no cause and effect, no cause and effect, no causation. Okay, but now we can conclude that using our dominant hand caused faster reaction times because we did random assignment. Okay, but there's a big but. We can conclude that using our dominant hand caused faster reaction times. So there's your X, there's your Y, explanatory response. Because we randomly assigned to treatments. That's the whole reason we get to do this. But only for students like you guys. I don't get to say that for 4-year-olds. I don't get to say that for 80-year-olds. I don't get to say that for me. I don't get to say that for sheep. Or, I mean, just picture all the sheep clicking the mouse. That would be really awkward for them, what with their hooves and all. Okay, now this is kind of the opposite. What can we conclude about a survey of randomly selected students' preferred number of tacos in an ideal meal? Let me give you a second to write that down. That would be great of me. That would be excellent teaching right there. What can we conclude? Children need time to write the sentence, Mrs. Talbot. Okay, we can conclude that all we can conclude that all of Mrs. Talbot's students prefer about 3 tacos on average. But we can't establish a cause. We can't say why. We don't know why they think 3 tacos is best. But we can say that about all of Mrs. Talbot's students think 3 tacos on average is right. You see the difference between generalizing to the population and establishing cause and effect. Okay, now prepare for Kahoot time, and you can have your blue sheets out, of course. That'll probably help you.
Brothers,